Okay, let's have a look now at the integral of e to the power of x dx. And remember that the derivative of e to the power of x was e to the power of x, so no surprise that the integral of e to the power of x is also e to the power of x. But of course, we've got the plus c because there could be a number out there, because when a number, when you get the derivative of a number, it's 0. So when we get the integral, we're going back to the original function, there may have been a number there to start with. When you got the derivative of it, of course it was 0. So anyway, the integral of e to the x is e to the x plus c. The integral of e to the kx, and so you've now got a coefficient on the index there, is 1 over that coefficient, and then e to the same coefficient plus c. Let's practice that. Okay, so here's what we've got to integrate, and I put the rule down the right hand side there, the bottom right hand side. So the answer, so it equals, now remember, we can take the 3 out of this, so it becomes 3 integral 4x dx, like so, and so the 3 sits there, and then we can apply the rule. So the rule says that when we integrate here, we get 1 over k, so 1 over the coefficient of x, so times 1 over 4, because the coefficient is 4. See it there? There it is, the coefficient's 4. And then it's e to the power of 4x plus c. So notice the index doesn't change there. And so that's going to be 3 on 4, e to the power of 4x plus c. Okay, next one, we've got e to the power of negative 5x over 4 dx. So e to the power of negative 5x over 4, if we just look at that, and this is this, we've done this a few times now, but you've got to recognise this. This is the same as a quarter e to the power of negative 5x. So what I can do with this, I can take a quarter out the front here, and there's the integral sign, negative 5x. I'll make that a bit clearer. Negative 5x. So there we go. And then we can just apply our rule. We've got our negative a quarter there, and the rule says that it's 1 over, so multiplied by 1 over the coefficient of x, which is negative 5, and then we've got e to the power of negative 5x. That doesn't change. So we get negative 1/20th e to the negative 5x. Yep. Sorry, just checking. I'll put my plus c in the last one. Okay, so we got it to there, and then it's plus c. So there's our answer. It's getting a bit cluttered there, so I'll make sure it's clear. There's our answer. Next one. Okay, this time we've got the integral of e to the power of x minus 1 squared. So the first thing we need to do here is to expand the brackets. So we get e to the power of x squared, so this is the integral of, get a bit better. Okay, integral of that, and then we've got minus 2 lots of e to the power of x. Remember, when we're expanding with a squared situation, we multiply those two together and double it. And then we've got plus 1, and put a square bracket around all of that, dx. Okay, and then it's the integral of e to the power of 2x minus 2e to the power of x plus 1. Probably don't need a square bracket now. Dx. So we integrate each part separately. So the integral of e to the power of 2x, okay, so it's 1 over the coefficient of x, e to the power of 2x, minus, okay, so the integral of negative 2e to the power of x is just negative 2e to the power of x. Integral of 1 is plus x, Okay, be careful there. You can start getting derivatives again and make it 0, which would be wrong. So the integral of plus 1 is plus 1x. Okay, and then it's plus c. And there's our answer. Let's look at the integral of sine and cos. Now, you remember the derivative of sine was cos, and the derivative of cos was neg sine. Okay, so if the derivative of cos is neg sine, if you've got positive sine, then the integral of positive sine is neg cos. And the integral, so there we go, neg cos. If the derivative of sine is cos, then the integral of cos is sine. And it's positive. So you just got to be careful there because it's the opposite sort of thing to what we had last time with differentiation. So just be careful with that. Alrighty, so there's the two rules. 1 over the coefficient of the x, then it's cos or sine, same bracket, plus c. So bracket doesn't change, and you put 1 over the coefficient. Sine goes to neg cos, cos goes to neg sine. That's practice. Okay. First one, sine 6x dx. Okay, so to get the integral here, it equals 1 over the coefficient of x, and because it's sine, it goes to negative cos, so it's negative 1 over 6. Negative, whoops, right here in a minute, negative 1 over 6. Cos 6x stays the same, plus c. So just applying that rule there. Sine goes to neg cos, 1 over the coefficient of x. With the next one, the 8 comes out the front. Integral of cos 4x dx. 8 stays there, multiplied by. Cos goes to positive sine, and we've got 1 over the coefficient of x. So coefficient of x is 4, so it's 1 over 4. There it is. Cos goes to positive sine. 4x stays the same, plus c. Tidy that up. 8 times a quarter is 2 sine 4x plus c. Next example equals, always put those numbers out the front. So just rewrite the question with 3 out the front of the integral sign there. Okay, equals 3 multiplied by the coefficient of x. Here we go again. What's the coefficient of that? That's the same as negative a half x. So the coefficient is negative a half. So now we've got a situation here where sine goes to, if we look at our rules here, negative cos. Okay, so it's negative 1 over the coefficient, which is negative a half. Okay, negative a half. See that all right? And then it goes cos, bracket stays the same, plus c equals, okay, so we've got 3 multiplied by negative 1 divided by negative a half. So 1 divided by a half is 2, negative divided by negative is a positive, so it's 2 there. And then it's cos negative x on 2 plus c. 3 2s are 6. 6 cos negative x on 2 plus c. Next question involves integrating a few different things within the brackets there. And what you do is just integrate them one at a time. Okay, so let's start with 2e to the power of 4x. So if we integrate that, it's 2 multiplied by 1 over the coefficient of x, which is 4, e to the power of 4x. So that's dealt with that one. Next one, negative 5 multiplied by 1 over the coefficient of x. And now sine, remember, if we go back to our rules here, sine goes to negative cos. So we've got to be careful with that. It's going to be, I should have put negative a half there. Oops, let's get the right pen. Negative a half there. And cos 2x, the 2x doesn't change, and plus 4x squared. The integral of 4x, remember, is we add 1 to the index. Okay, so it's plus 4 times x squared over that same index. So have a look at those three, and that is really good actually, because it shows us all the different integration skills that we've learnt so far. Mustn't forget my plus c. So 2 times a quarter is a half, e to the power of 4x, plus 5 on 2, cos 2x, 2 and 4 will cancel there, plus 2x squared, plus c. There's our answer to that one. Next question. Find f of x if f dash of x equals 3 cos x over 4 and f of pi equals 9 root 2. So here we are starting to get to a real typical exam standard question. So to find f of x given f dash x, we've got to integrate, because remember the whole point of integrating is going from derivative back to original function. And we'll probably end up using that, no probably about it, we will end up using that to find our plus c at the end, value for our c. So let's get started. So what we have to do first up is integrate 3 cos x on 4 with respect to x, and that will be the same as 3 when we take it out the front, cosine x on 4 dx equals 3. Remember, cos goes to sine, so there's no change of positive to negative. Cos goes to positive sine, so 1 over the coefficient, which is 1 on 4. Remember that, the coefficient of x on 4 is 1 on 4. Sine x on 4 plus c. 1 over a quarter is 4. 3 fours are 12. So if we come up here, it's going to equal 12 sine x over 4 plus c. Right, now what's the c? Well, we're told that if we put pi in for x, so f of pi, we're going to get 9 on 2. 9 root 2, sorry. So let's now, to find our c, we're going to get this little equation here. 12 sine, I'm now substituting x for pi, pi on 4 plus c equals 9 root 2. So you can see I've done what's in the yellow box there. I've found, given that f of x, I should have written that in really, given that, let's get it there over a sec, given that this is f of x, then f of pi is putting pi in for x, and that's what I've done there. And we know that f of pi is 9 root 2. Now what's sine pi on 4? Okay, we can look at that up in our information sheet, or we may remember that it's root 2 on 2. So 12 times root 2 on 2, which is sine pi on 4, plus c equals 9 root 2. 2 and 12 will cancel. 6 root 2 plus c equals 9 root 2. Therefore c equals 9 root 2 minus 6 root 2, which is 3 root 2. So what's our equation? Okay, we've now found our value for c. So f of x equals 12 sine x over 4 plus c, which is 3 root 2, and we've got our answer. Right, this is quite a difficult question, this one. Once again, exam standard. In y dx equals sine pi x on 6 plus k, where k is a constant, so a number, and y has a stationary point 3, 4. Find the value of k, find the equation of the curve, and find y when x equals 6. So let's start off by finding k. Now, one thing that we know, is that we've got a stationary point where the derivative equals 0. So let's start by making the derivative equal to 0. So sine pi x on 6 plus k equals 0, because we know there's a stationary point when the derivative equals 0. Now I can see there's a stationary point here at 3, 4. So we have the x coordinate of that stationary point, so that can go in here. So sine pi x multiplied by 3, which is the x coordinate of the stationary point, plus k equals 0. Sine 3 pi on 6 is pi on 2, plus k equals 0. Sine pi on 2, that's be on the table on our information sheet, is 1. No, not 1, sorry. It's 0. Let's check that just a moment. Okay, I got myself a bit confused there, so I rubbed out that last line. So sine 3 pi on 6 is pi on 2 plus k equals 0. Sine pi on 2 does equal 1. I don't know why I mucked that up before, but anyway. 1 plus k equals 0. Therefore k equals negative 1. So we've done question A. The value of k is negative 1. So that makes our dy dx then. That makes our dy dx. Now we know the value of k. It's sine pi x on 6 minus 1. Alright, now we're going to find the equation of the curve. Now remember, we've got the derivative. Right, we've got it there. And to find the equation of the curve from the derivative, we integrate. Okay? So let's do that. So the integral of sine pi x on 6 minus 1. Okay. First of all, sine goes to negative cos, so it's negative 1 over the coefficient. Coefficient of x is pi on 6. Minus 1. So the integral of 1 is minus x, minus 1x. Oops, hold on. Before I get to that, I needed to write down my cosine. Cosine pi x on 6. Okay, then the integral of minus 1 is minus x. So that will equal, now negative 1 over pi on 6, turn it upside down, we get negative 6 on pi. I've got my plus c there before too. Cosine pi x on 6 minus x plus c. That, ladies and gentlemen, is our original equation. Here it is. Okay, now we need to find our plus c. So let's copy that over to the next slide. In fact, I might pause here and just write that a little bit more neatly because it's a bit messy. Okay, now what we need to find for our equation, because remember that's our second question here, find the equation of the curve, there it is. And what we need to do now is use that point that we're given. It's got a stationary point, 3, 4. So we know it passes through 3, 4. So let's write that point down. We now substitute that into here. So it's always our strategy for finding that c, once we've got an equation like this, is we substitute in our x and our y value. So that's minus 3 plus c. Alrighty. So 4 equals negative 6 on pi. Cosine 3 pi on 6 is pi on 2 minus 3 plus c. Now, cos pi on 2 is actually 0. Right, so that makes this whole expression here 0. Okay, so cos 90, cos pi on 2 is 0. So negative 6 on pi multiplied by 0 is 0. So, next line, because that basically goes out, we've got 4 equals neg 3 plus c. C equals 7. So our equation is y equals negative 6 over pi cosine pi x on 6 minus x plus 7. Our last question says find y when x equals 6. Okay, so find y when x equals 6. Therefore, we put down y and we're making x equals 6. So cosine 6x, sorry, not 6x, back a step, pi times 6. Sorry, just going back a step, yep, x equals 6, minus 6 plus 7, y equals negative 6 over pi, and the two 6's there cancel, so we get cosine pi, minus 6 plus 1 is plus 1. Cosine pi, okay, so you look up cosine pi, and that is going to be negative 1. So y equals negative 6 on pi multiplied by negative 1 plus 1. So y is going to be 6 on pi plus 1. And that's the end of that question, ladies and gentlemen. Pretty difficult one. Hope you could follow it through. So that's the end of Integral Calculus Part 3. And that now enables you to do exercise 9b. And the good thing about that, we've done our basic types of integration now. So it really sets us up for this unit.